Have you ever wondered how an unconventional topic like sequences and series is used in the real world? You might think that a geometric progression is of no use, but that's not the case. A geometric progression is of vital importance. Hello everyone, I'm Siddharth Mishra of class 11th from Balbharti Public School, Pitampura. I would like to invite you to venture along with me to a fascinating journey of exploring the various uses of sequences and series in the practical world. But first, let us learn something about a GP.
What is a GP? A GP or a geometric progression is a sequence of numbers where each term after the first one is found by multiplying the previous one by a fixed number, which is also called as the common ratio. Let us understand this through a simple illustration. We have a sequence, say 1, 2, 4, 8, 16. Can you observe the pattern? You get the next term by multiplying the previous one by 2, which is a fixed number. A general term of GP can be formed by the formula Tn is equal to a into r to the power n minus 1, where n is the number of terms, a is the first term, and r is the common ratio.
Let us take the first example of a bouncing ball. Let's say you're on your balcony at a height of 4.9 meters from the ground and you're standing with a cricket ball in your hand. The ball slips from your hand and lands on the ground. After the first bounce, the ball moves up and attains a height of 81% of the original height due to loss of energy to the surroundings and goes back down, and after the second bounce it again attains a height of 81% of the previous height. This will form a decreasing GP, and to find the time of flight of the ball, i.e. when the ball is in air or the distance the ball travels, an infinite GP is used.
The time taken by a ball to fall through a height h is given by under root 2h by g, which is derived from the Newton's laws of motion. The total time of flight can be obtained by adding the first time of flight and the twice the time of flights of the subsequent motion, which is under root 2h by g plus twice of under root 2n h by g plus under root 2n square h by g plus under root 2n cube h by g, and so on till infinity. Here n is referred to as 81%. After further solving and applying the formula of an infinite GP, we get the simplified expression as under root 2h by g plus twice of under root 2nh by g into under root n upon under root n plus 1. Further simplification results in the answer coming out to be 19 seconds.
Another example can be illustrated in the case of radioactive decay of heavier elements in the periodic table. The heavier elements contain either too many neutrons or too many protons, making them unstable. They emit subatomic particles in the form of electromagnetic radiations to balance out the number and to attain a lighter, more stable state.
The application of geometric progression could be easily seen by applying the formula of radioactive decay. The number of radioactive nuclei present at any time t is given by the formula n is equal to n naught into e to the power lambda time, where time is in the exponent. Here, n naught is the number of radioactive nuclei present at time equal to 0. Further, the nuclei disintegrate or decay and decrease. So, the common ratio in this case would be e to the power lambda, and the number of terms would be found by knowing the value of time.
One of the most crucial uses of a sequence is in the field of finance. We can trace various examples of a sequence being used in the field of finance. Let's take an example of a man who has planned a great investment. He invests rupees 7,000 on the first day of every year and the accountant pays a 10% interest every year, compounded annually. After the first year, the man will have 7,000 into 1.1. After the second year, he will have 7,000 into 1.1 whole square. After the third year, 7,000 into 1.1 whole cube. And we can see that this forms a geometric progression, with the first term being the initial investment, which was 7,000 rupees, and the common ratio being 1.1. We can take another important example here. Let's say a man joins a firm with an initial salary of 30,000 and an increase of 5% every year. After the first year of work, he'll get 30,000 rupees. After the second year of work, he'll get 30,000 into 1.05. After the third year of work, he will get 30,000 into 1.05 whole square. This forms a GP with n minus 1 terms and the first term as 30,000 and the common ratio being 1.05.
In the end, I would just like to say that a sequence is of vital importance and is not just used in the physical world. We all want our wealth to multiply in a geometric progression or our joys to multiply in the geometric progression. Thank you.